So this is when you deploy the virtual machine, you're going to come to a screen that looks like this. It's pretty boring. It's just a target configuration. So you can see the targets and all the modules that we add. It's relative to the hypervisor, vCenter, Red Hat, Hyper-V, Zen Server, OpenStack, VMM, ties into AWS and Azure, as well as vCloud Director, CloudStack. Storage support into NetApp, VNX, 3PAR, and Ender, I'm sure, can explain some of the future integrations we're doing. In additional to the NCM module, so we go through a NetFlow collector, so it'd be a Linux machine that you deploy. You emit your DVS or your Nexus switch to emit those stats, and we essentially target that to detect which VMs chat together. So when we add these, this screen should probably look familiar, but what we essentially do is we mediate it. We bring it into that abstraction model that treats it as one uniform thing we need to control. So everything that we're adding becomes a way to kind of increase the ability to control the problem we solve. So I'll start with a couple examples on the core product before the modules. We can go into some of those actions and what they do, and we can kind of build out in terms of the complexity of the use case so you guys can get a good kind of time frame on how this developed. But when you think about the base of the triangle, it started with workload, right? Virtual machines, physical machines, data stores, everything we can pull from something like vCenter. Now, when we think about what we can do to control this, it's everything at our disposal. So in a matter of minutes, we do the discovery, we map those relationships, we turn it into a market of buyers and sellers, and the actions begin to define themselves. You don't have to set up the rules, you don't have to set up heuristics, thresholds, all of that is old concept. You don't need to do it. So when we do this, you're going to see a very different experience. In a group of, let's say, 2,000 virtual machines, if I viewed the amount of risk in my supply chain, it would be things throughout that entire stack. A NetApp volume is full. My host is congested for CPU. I have memory congestion. I have risk for partitions. I have risk for reservations. I have ready queue. All the things that a human could interpret are what we want to drive and prevent before that happens. Now, at scale, what this means is under an hour, we begin to define those actions. So we begin to present in an executable format the exact decisions I need to take to drive my environment into a state of health. Well, let's go to the example on DRS. What if your HA constraint is passed? You can move VMs all day, but that's not going to satisfy performance. The decision you want is to provision a new host.
Are you using standard financial risk analytics to perform these kind of judgments? Are you using like beta? Are you assigning a beta for anything that's not mapping to the standard deviation of?
So we actually,
I mean, you use the term risk, and you talk about a whole lot of other financial things, so I figured I'd ask.
Yeah, maybe you want to help explain the pricing function?
It's much simpler. We're simply, we're not dealing with derivatives. We are simply dealing at this point with buyers and sellers of commodities. So think about a very, very simple commodity market.
Okay.
And every resource is priced. It is priced based on its utilization. In fact, the function that we use is an exponential function. The reason that we use an exponential function as your utilization increases to the full capacity of whatever that resource is, the price increases to infinity, is because that is a pretty good approximation of how latency or delay or service delivery delay is behaving in a way you approach a full capacity of whatever resource you're providing.
So since it's a finite resource, you just assign it infinity when it hits whatever the market cap is.
Whatever the maximum capacity.
The higher you use that resource, the higher the price. So the price represents the delay. And as that dynamically changes, the workload determines the action to control itself, right? So there's multiple price curves. So what we're essentially doing is finding the intersection of each of those, right? Because I'll give you an example. So we tell you to increase the vCPU limit on a virtual machine. Well, I can clearly see that this is trending at 93%. Now the question becomes, okay, I could get an alert to this once my demand has gone past a certain point. The decision is where the pricing function comes in, because what if I increase this and the demand changes? Well, that changes the price curve on the CPU on my host. Now CPU goes up on my host, other buyers and other demanders are impacted. Now that's typically what we leave up to a human. Well, what this looks like to us is, hey, your price is really high for CPU, size yourself. But when you do this, check your underlying capacity. Is the host it's on enough to satisfy that demand? What if the decision I need to take is to move this workload to a different host? What if I don't have the host? Then the decision I need to take is really to provision a new physical machine. And you can look at sizing in the same way. We think that sizing reclaims tons of resources. If you look at a report that tells you 97% of your environment's over-provisioned, what is actionable out of that? What's going to get a yield to your actual desired state? Because if I'm reclaiming inactive pages, I don't do anything to performance, and I'm just taxing my system. So what about something like decreasing from 2 to 1? So now the price on ReadyQ is risky. That could be a combination of actions to control this. I need to decrease it, not for efficiency, but in order to actually
Did you create that mitigation, or did the system?
The system did, automatically.
And you can tell it based on which applications are important, right? So
yes.
This whole model you can align to your most important app.
Yes, that's a very, very important point. In this environment, you not only want to just simply satisfy all the demand, you want to allow for differentiated services. You have mission critical applications, you've got applications that are not so important, especially in an environment where your shared infrastructure is getting higher and higher utilized. You want to make sure that the applications that are really important get the resources. So in addition to what we just briefly touched on, we have each entity deciding for itself where it buys its resources in the context of what the prices are, as well as in the context of how much of those it needs, and based on that decides where it should run. We also allocate a budget and different amount of budget to each one of these applications. An application with a larger budget has a higher purchasing power, and an application with a lower budget has a lower purchasing power. So if your infrastructure is becoming underutilized, the applications that are low priority applications, in our context they have a low budget, won't be able to afford the resources. We are able to shut down or constrain, limit those resources, hence assuring that the applications that have high budget that are mission critical will continue to get their resources. Meanwhile, we're going to also identify where you need to possibly add more resources if this continues to happen in your environment.
Can I go back to that CPU example you had for high CPU utilization? Is there a root cause type capability in there? Because sometimes your application is truly using 90% and it needs to be grown. Sometimes it's an out of control process on the box that needs to be killed, or the box needs to be rebooted. So does it have any visibility or insight into as part of it?
Yes. So the question I would answer, or the way I'd show you it, is probably even a better solution than you're expecting. So typically you'd be looking for an alarm that says this process is rogue. What we look at is what action can we control with that use case, and it's one of the things we thought about. Mm-hmm. So when you think of going into the application now, things like WMI for Windows, SNMP for Linux, remote JMX for Java, heap size. So even if I get a report on my OS that my memory's inefficient or overused, how do I know whether my Java heap is sized correctly inside my guest, or my guest allocation is sized for that? So there's always going to be the black swan use cases that you can't avoid. So now we deliver actions on that. So you come in and you say, I'm going to discover this, all my discovered processes that I want to look at, so SQL Server, whether it's antivirus, IIS, my JVMs, you discover that, and now it becomes a buyer in the market. So now you have two buyers consuming the same guest. If antivirus is the low priority buyer that is beginning to essentially cause my supply to go up, we know that's a low budget application. The action we want to drive isn't to increase and feed the problem. Mm-hmm. It would actually be an action that you would see to suspend that application. So now we deliver an action that would be prioritized on that main screen that says, yep, that is a low priority action. What you really want to do is suspend.
So question around that as far as the security goes of it, is there a level of granularity because in order for it to perform functions on the virtual machine, it needs credentials to access that box, probably through Active Directory or something, or root credentials if it's Linux boxes, right? Do you have the ability to assign granular credentials if you have box here has these set of credentials, this other box over here is on a different domain, etc.?
Yes. How does it actually, is there an agent to install on the VM, or does it do it via VM tools, or how does it talk inside the VM? So
there's two things. One is that our core value is not about getting more data. There's plenty of tools that get data. So we've got a number of customers who already have deployed their own agents. We have the ability to take information from each guest operating system, feed into the system, drive the exact same analytics that Eric described. To make the deployment easy and not be dependent on any particular agent technology, our software is not. We have the ability to take advantage of out-of-the-box instrumentation, agentless technologies like WMI or SNMP. Well, SNMP to the extent that it's already part of the operating system. So all the information, short of having an already deployed monitoring system, we rely on these agentless technologies, built-in instrumentation in the guest operating system to acquire this data.
With what Christopher was saying, with some sort of authentication mechanism that you maybe only have read access to WMI.
Yes.
Okay.
Yes. And you can be very granular and say that, this group of applications will use these credentials, this group will use these credentials, and these, you never touch them, you don't even try to communicate with them because you're not supposed to. So you have full flexibility in how you manage those credentials.
Are you still looking into doing PowerShell stuff, or is it too slow compared to WMI? Because when I reviewed VMTurbo last year, they didn't want to do PowerShell yet.
So on one hand, there are aspects of how we mediate against certain technologies where we do use PowerShell, specifically in the context of without another agent. If you want to feed information into our software as to how applications are performing, how processes are running in a virtual machine, we are still using WMI. I think that what we really want to do is to see how what is the most commonly available and most efficient technologies, and sometimes in terms of getting metrics may not be something that we develop, it may be something that we leverage from a customer. You've got BMC Patrol, you've got HP OpenView rolled out in the environment. I really don't want to write a better collection agent than what those guys already done. What I think is really important for me is how do I feed that information into our system so that we could drive those actions that Eric explained earlier. So while we will try to make the deployment easy, our value is really to focus on how do we drive best decisions based on whatever data we can get to.
We'll have to hack the Windows registry on a Hyper-V host to install VMTurbo. Like change the trusted installers subkey. You still have to do that?
True.
Okay.
We're blaming Microsoft for that one. We did have one question that came up from Amit and Mark. I'd seen some back and forth, which is good. This is the classic question. I always love when this one comes up. We used to call it, why not VC Ops? Or what do we do other than VC Ops? Exactly. Which now is realized operations. So it's always a tough one because we never want to look at A versus B. So I should draw a picture of an apple and a banana to show the difference, because if you drop an apple and orange, they look too close. There you go, banana for scale. That's for all the Reddit fans out there. So maybe if you want to talk, a lot of stuff that's just come up is very important to that conversation around what vRealize operations and VC Ops are versus what we're doing.
Can I ask one question before that? Because sure. Sean Massey, vExpert, just to clarify his question, he says, so with VMTurbo, you can manage applications and services running as VMs rather than just the resources, right?
Yes. Yes.
So just to clarify that, which is awesome.
Yes.
That's good. That's really good. Now go ahead. I just want to get that out of the way because that's great.
Okay.
Sorry, can I just ask something before we go on to the other one? Sure. The grouping you're showing over there, is that how you then group and group VMs together for the priority? Because obviously your print server you don't care about, but your Exchange server is your potentially your highest performing one. You're talking about all the consuming and the economic model, but how do you actually categorize which VMs are important and which aren't?
So it depends on if you have the native constructs, folders, VC annotations, clustering, ways that you've already defined that. We pick that up. So you could define the prioritization based on the groups that already exist.
Could you use resource groups, for example?
Yeah, exactly. One of the things that's good, though, and I know we want to get back to the original question as well in a second, but we use regex to group things dynamically. So based on criteria now, if you wanted to create your own group of entities based on things like connection to storage, hosted application, name, so if everything has SQL in it, you want to match that dynamically. Anytime you provision a VM based on that criteria or an object, it automatically gets added to that group. So if you have an automation policy or an action policy or a prioritization, anything you do to that group carries over as you add and subtract from it. You don't have to go back. So it makes it very scalable.
That's definitely a good benefit. That's a far more application-centric view of monitoring and management than just dumb VMs that are all equal.
Yeah. I think ultimately we are running applications, so for us the ultimate goal is to assure the performance of the applications. We have to be aware of and granular enough to manage applications, not just manage VMs. Of course, to assure the performance of the applications, you also need to manage the VMs and everything underneath that.
And I think to the original question, I don't want to direct it just at the competition, because I've been told I can't talk about the competition.
We're trying to be non-competitive, but we'll talk about comparative.
I will say it in terms of if you remember that loop slide. It's, there's two kind of worlds that have evolved. One is the viewing and one is the doing. And there's tools that are really good at the viewing. There's tools that are really good at the doing. But RCA, by definition, can't be accomplished in software. It's too complex. It needs, there's no software tool that's going to be built on a platform for RCA that can scale enough to actually do that. There's always going to have to be a human involved. So when it comes to technologies that have been built on the viewing framework, what we're seeing a lot of is they're trying to incorporate the doing aspect to it, but by design, it's built on a system that's solving the problem of anomaly detection, right? So that CPU example is a great example. That might be an anomalous alert that isn't normal. That might be something that I see that goes up, but that's delivered as an output of the design as a shortcut to act, right? It still gets delivered to a human being. They have to interpret that, and I can't remember your name in the back corner, but they still have to analyze, is that a rogue application? Is it a mission critical application? Do I have the supply in my host? What action am I going to take to try to solve this? And then you think of an environment of even over 500 VMs, even if you have rules, PowerShell scripts, and actions to remediate, contextually it doesn't understand the bigger picture of how are all these moving parts kind of achieving this single goal. So I'd say abstractly the main difference is the problem definition that we're trying to solve, and the output of that design that we deliver as a result of solving that. Does that help?
We like to think of a classic thing that I use as a comparative is, say you're doing something and you can choose to do root cause analysis, which we know systematically is very difficult to do, and in fact, no products really do it correctly. But let's say you're doing something like parachuting. Now, do you want to have continuous real-time control over what's going on, or do you want to just have something go terribly wrong, wait till you get to the bottom, and then go do some root cause analysis on what just happened? I've got bad news for you. You're not the one doing the root cause analysis, right? And if this is your data center, and effectively you're left in charge, and we want to control things by controlling it through a human, but when you in fact relinquish control to the system,
I think that's
you could take the next step, which is this thing can start to forecast your month-end spike in demand.
Oh,
right?
Hey now.
Once a month, your finance people are closing the books, and that puts a lot of load on a SQL VM. And I seem to remember that this could do that.
We've built on that even more into a couple different ways. So the future workload represents a demand that doesn't exist yet, but it's still something you want to prepare for. So what we've actually done is you can't separate that from what you do in real time, right? Because those future workloads and those things that haven't happened are going to impact the decisions you're making currently. So you don't want to view it as this is one tool that does this in us, this is another tool that does this. It's built on the same abstraction, the same goal. So we've built off of this, and one of the things that's pretty interesting is the concept of reservations. So you go to hotel.com, what are you you're reserving a hotel room, your VMs can actually reserve space in your data center. So let's say from the list of the customized specs that you guys have, SQL being one of them, where am I okay with this going, right? So I know at the end of the month, I'm going to deploy 20 SQL servers into my environment based on where it can go. And these are just the customization specs within vCenter that we pick up. And you call it test SQL. So now effectively what you're doing is you're saying, I'm not going to deploy this today, but I want to reserve this for the end of January. And the recommendations will come up if you placed it. Where do I place it today? But more importantly, it becomes an active reservation in your system. So we treat them almost like ghost buyers, right? They're buyers that don't exist, but they live amongst your application workloads. And basically, the other VMs become aware of them. They say, hey, I need to make room for these 20 SQL servers that are coming. So now that actually defines the decisions we do in real time without that future demand even being there. Now, let's say the end of the month approaches, and you don't have the resources. Well, that reservation switches from an active reservation to pending. And what actually just came up is, I can't do it. Even in a month from now, I don't have the current resources to deploy this, and it's telling me I can't do it.
So you're taking over basically reservation pools from within vSphere and doing it here.
Well,
adding basically analytics to it, right?
Yes, that's correct. I think what's important is the context. We are managing these reservations in the context of what applications are going to be deployed, and we figure out what resources you're going to need to run them, rather than a human having to say that if I need 28 VMs, that means 2.8 gigahertz of CPU, so I need to really set this reservation to 3.45 gigahertz because then I'll work. So basically everything in our system starts with what the demand is, and then it then calculates what infrastructure, what supply do you need to be able to satisfy this, without a human having to do that calculation and to manage that in real time or in the future going forward.
The resource pool challenge is that I've used a lot of resource pools for specific things, and one of the problems we have is that it's not dynamic. It's dynamic in some sense, but additions and removals aren't in there, and that's the good thing with the grouping. And us is like through straight regex, and by behavior, natural behavior, it will dynamically make those choices for you. Versus me, I go and I put these 7 VMs in there because they're my workload that I choose as this application. And then my developer deploys a bunch in, and maybe I've been lazy and I haven't written some cool Power CLI script that will automatically put them into a resource pool, or I forget to run that as a scheduled task somewhere. Like that, every single piece of that is as automated as it is, and believe me, you're talking to a guy who loves automation because I'm fundamentally lazy. But I like being so lazy that I can just leave it to running completely dynamically based on actual demands, which is cool.
My only fear is, so you're taking away the view of other people who have access in vCenter. If they don't have access to this, they don't know what resources are what. Does that make sense?
That's true, but that problem is actually bigger, right? Because looking at vCenter, you may not be able to tell anyway how your underlying storage is going to be able to satisfy the demand. How many network ports do you need on your UCS fabric to be able to satisfy the demand? How many blades can you plug into your chassis? You don't know what those applications are doing. So in a way, I think it's really important that what we want to provide is a unified control system. In that sense, your virtual infrastructure is an integral part of that, but it's really just a part of it. What you really want to manage is application demand across all of the infrastructure that is required to deliver that.
You get a lot of false positives when you try to understand what's going on in the environment. When they, just like if they're using Task Manager in Windows and they're saying, my CPU is spiked.
Right.
But is it really? Is it really spiked? Or is it because you open Task Manager and it's spiked?
Well, it's also...
So just because they have access to metrics doesn't mean they have the intelligence to understand them. And thus, when they have direct access to the vSphere client, and remember, this is not just vSphere. This is AWS. This is going out to Azure. This can be pointing to your Hyper-V environment. So you have got all these different, and a whole nest of other options. I mean, those are just the short and easy ones. It gives you the ability to gain intelligence and analytics into all of those, so that way you can ensure your applications are operating the way that they can. Does it provide you the ability to migrate between them? I don't know if it does.
So
thought.
Yes, it does. So one of the things that the demo that we have done is to demonstrate how we take a virtual machine running on a VMware environment, migrate it to Hyper-V, and migrate it from Hyper-V to Azure. So the analytics absolutely allows you to do this. It allows you to move across clusters, move across data centers, and move across any hypervisor technology, and simply because we're using a single unified abstraction to represent the whole infrastructure. So to the analytics, all hypervisors, all virtual machines, all applications look the same with their respective priority, with their respective utilization, with their respective demand and their prices. Now, there are some cases where the orchestration is really easy, and there are some cases where the orchestration is more complex. So what we also allow people to do, and a number of our customers are doing this, is to run our software to be the brain of your whole data center, drive these actions, and instead of us natively implementing the actions, call to an orchestration system, call to Scorch, open a ticket in ServiceNow, go through a change approval workflow, and then come back and say that, okay, I've executed this change. Our software is going to identify when the changes that we have, the actions that we have created are executed, and it will adjust even if it didn't execute the change itself.
It's also, we talk about the network control module. This is an important concept of where the modules kind of bridge together, because you don't want to migrate an app server to AWS when you leave the database behind if they communicate, and vice versa. So now the logical transition is, so if we know the group of VMs that chat together, move that vPod to Azure, or move the vPod to AWS. So the idea of bursting groups of workloads, rather than you interpreting that application topology and which ones chat, have the demand actually determine itself and deliver those recommendations.
So out of the box, I've got a connection to each of these cloud service providers. Rackspace, does it support Rackspace? Just yes or no? I mean, because my actual question is...
Today we are supporting Amazon and Azure.
What's the level of configuration I need to do to say, hey, I want to move this workload from here to there? How much work do I need to do for that to actually be possible? Is it click, click, click? Is it I need to write an extensive API? You know, what's the level of effort as an end user who has this as a product, who wants to move an application from one provider to another?
So do you mean to enable our software to identify the action of where the application performance is going to be assured, or do you mean to actually orchestrate the move of the VM?
You got it.
To actually move it.
To actually move it.
Okay. So we basically have a fairly simple API, RESTful API. On one hand, you can trigger a script, trigger a web service. Through the API, RESTful API, you could get more details about exactly what the action was that our software identified. The actual orchestration really depends on what you're trying to do. The reason that we have done the Microsoft work with Azure and Hyper-V is because there was a pretty cool little tool that Microsoft provided to actually implement this. So what we've done is that we use the exact same hooks that we export to all of our customers, made that call, and it ended up executing the actions without much of a coding. There may be some actions that may be more complicated, so there may be more code. What you get out of our software without any work is the exact action of, for example, this VM, move here, this application needs to be cloned here. And then how you actually orchestrate this is a script, a Puppet, a Chef, a Scorch,
So but out of the box, it doesn't have that script functionality built in where I fill in source, destination, and it goes and does all that work on the back end. That's something we have to bring.
So we have done this for a lot of the things that are pretty much out of the box available everywhere. We are moving a VM across any cluster within a virtual center. We are moving a VM in a Hyper-V environment across cluster shared volumes. Yeah. We are live migrating a VM in an OpenStack environment. We are cloning a new VM on Amazon if you need to scale out an application. We are changing the load balancer configuration to scale the application out. We are growing a NetApp volume. We are migrating a volume from one aggregate to another. We are scaling out a NetApp aggregate automatically. So there's a whole slew of actions that the actual orchestration, the actual implementation is built into our software, and it can be fully automated. And you have the option of either replacing or adding anything else to it.
Just to be clear, because it seems sort of unclear, because we're talking about it being unclear, it's so I can right-click and say, migrate this thing to a cloud service provider, and I just have to provide source and destination. Or I have to bring all of the automation and do the work myself. And then it can automate it once I've already written all those processes of orchestration.
Okay, so specifically cross-cloud migration, we have not embedded the actual implementation in our release.
That's what I was looking for, okay. Yep. But if you're doing Hyper-V to Azure, most of the work is already done for you because of the automated features that Microsoft has provided.
Yes,
so.
correct.
And as every new discovery that we make through customer interactions, and in fact, I saw Amy posting some stuff up on our Green Circle community. More stuff like that is popping up on those community boards. Effectively, opening the doors for everybody else, which is cool. And
you're rolling it back into the product kind of thing.
Ultimately, yeah. When we see that feedback come through, and if customers give us that use case, and we see the value in being able to share that use case amongst other customers, then we put that work in there. We have a very cool iterative approach to how we deliver software.
It gave us a good 23 items of a use case that all would be great things you can roll into the product.
Yeah.
So I think it's really the combination of both, and our goal is really to enable our partners and our customers to be able to innovate and contribute things and share it. And this is really what we're doing through the Green Circle community. So it's not necessarily that we have to do anything. It's not necessarily that they all have to be part of the product, although it's a very good point that if 9 out of 10 customers wish a particular orchestration to be available out of the box, then they may not need to go to the Green Circle. It can be easily rolled into the next update.
I mean, the reason people don't do things natively is because it's hard, it's painful.
Yeah.
But if it's you can just do that. People will typically do that, and they'll flock towards it because, hey, well, I get VMTurbo, I can just move my stuff across the clouds. I want to explore with OpenStack or a shared public version of it, and I don't want to have to do all the work myself. Oh, this tool does it all for me because it's been tried and true and tested. Now I can start practicing and testing it in that way. I mean, that's the kind of mentality of the general purpose community of users versus the highly active DevOps types of folks who are like, I'm just going to write my own API. I'm just going to do it this way.
So we won't stop the DevOps people to do this, but we really want to make it easy for people to use this software to the extent that we can embed it in the product and to the extent that we can enable the community to share it with each other.
Yep.
One question had come up earlier, and we'll take it outside just because licensing is never something that a whole bunch of people want to watch. But Christopher and Amy, you'd had a chat about licensing. We'll talk to you after about what's baked in and what's freely available and the other sort of layers of features that come with different stuff. But we don't want to bore those fine folks on the camera with all that good stuff.
All three of us still have something.
I wanted to ask about the economic scheduler a bit. So if yours is simple, then we'll do that first.
Mine's simple too.
Yeah.
There's downtime involved on a virtual machine. There's something out of the box that says, I'm just talking about just because I saw increase capacity or decrease, go the other way, decrease. Is there something out of the box that says, don't perform this action, alert, or don't perform this action, do something else? Does it recognize a reboot must be required?
Yes. So one of so this comes down to the level of automation of how do you want to execute the action. The action is probably the right action anyway. The question is how do you want to do this? One of the things that we are allowing you to differentiate is intrusive actions versus non-intrusive actions, and you can choose to automate non-intrusive actions such as sizing up a VM in most of the operating systems. It's hot-add memory or hot-add CPU is available, and you could choose to automate intrusive actions differently. You could choose to maybe go through a change management process for those, but automate the non-intrusive ones.
Yeah, I think setting a schedule for it.
Yeah, that's for any action type. But I think to your point, even if you can elastically automate size up, think about how dangerous that sounds. I mean, the only way that you can do that is with an economic model that knows where that capacity is coming from. Because at some point, you're going to hit a roof, right? And you're not going to be able to auto scale up, and the action might be to horizontally scale. So the encouragement we're giving is that because there's an intelligence behind why we make these actions, automation isn't just a point and click thing that's done based on this thing in isolation. It really understands that whole picture. So for efficiency, absolutely, you start with low-hanging fruit. You say, I won't say test dev because I don't know how many people are in test dev, but you start with a test machine or something, or a group of virtual machines you can do that on, automate it in a window, and you can create action scripts to this too. So one of the things that a large client does on VDI, so persistent desktop, about 20,000 of them, it goes out and it asks, okay, is the user logged in? If the answer is true or false, go back, take the action if they're logged out, reboot it, bring it back up. So there are things you can do that I wouldn't say it's necessary, but if you're really thinking about enabling elastic sizing across an enterprise, you want certain change controls. Maybe you want it to go to Remedy or ServiceNow and say, pre-approval, open a ticket, size it, send me post-approval. So those are all things that we do for all of our enterprise customers today. So you can effectively do that. Mm-hmm.
One point that came up around, and we see it a lot in the industry, and it's being talked at the table about like features, like can we just move from one place to another? Can we do those things that we know would be popular? But the challenge we've got is, and like DevOps and ServiceNow integration, all these things. Typically, it's that thing. If you ask the question, can I just buy this, product for X dollars per socket, and then it will automatically become DevOps, right? And that's the old thing. Like, I'm going to hire a DevOps manager or a DevOps team. Like, oh no, you don't. That thing doesn't mean what you think it means, right? So it's a challenge. That's when we get into some of these things, it's more about enablement. And then what we do well is what we really, really, really do well. And then we also enable folks that do those things well to do it and then share it out.
So Rick asked a question a while back that I just never made it back to. When you're calculating if you're going to move, say, just between two ESX hosts in a cluster, I assume this is a given, but you will respect existing DRS affinity and anti-affinity rules, yes. Right? Okay, yes. Just want to make sure.
Interestingly, by the way, all of these constraints, including the DRS rules or any other business policy, licensing, compliance, become just another commodity in our system. If you want to have two VMs sit apart from each other, you can have a commodity that is sold at a capacity of 1. So only one VM can buy it at a time. If you have for software licensing, you have to run a VM on a certain host, then you can sell a commodity that sells the exact number of licenses that you have. And not only that, it's going to assure compliance to those licenses, but it's actually going to tell you when you need another instance, and it's going to tell you that I need to scale out my supply. I need to buy another host with this software license, because we are managing the supply in the context of the demand. You could actually manage any resource, not just CPU memory, software licenses, or assure compliance.
I think to that point, Ender, too, is that this is almost an enabler to be able to break some of the constraints that we traditionally think of. So there may be some rules that you realize you don't need, right? So resource pools, things that constrain us in an environment, and that could include across clusters, right? So maybe we say, I've got 4 large production clusters, but my cluster is becoming a constraint itself. Well, that becomes something that doesn't matter to us. So what if I actually wanted to say, this is a migration zone that I'm okay with VMTurbo making recommendations across. And because it understands the workload demand, we don't need rules within that to say, well, what if we place unlike applications next to each other that cause interference, because we manage that in the market. So there is an opportunity to eliminate a lot of the constraints that we traditionally think of in order to let the free market kind of determine some of that as well.
How many people have created resource pools and then added enough machines to the point where you suddenly get that warning that says it will not be able to service the resource pool, and you just jam it in there anyways because you don't have a choice, right? Now you've created a constraint. You already had a constraint to begin with, you just didn't realize it. Now you've been told you have a constraint, you still clicked on OK anyways, right? And that's, let the dynamic engine do that for you without having that constraint live in that vSphere area.
So just because an interesting segue into this, I think, the same way as we allow each entity, each application, each virtual machine to make its own decisions on where it is best for itself to run based on the resources it needs, based on the prices it needs, we also, with the same economic scheduling engine, let each entity that provides resources drive how much of it itself how much of it is required based on demand. Each entity measures the money it makes by selling its commodities to the resources, and it also measures the amount of money it spends on being in the environment. Like a host has to spend money on power and cooling, and it makes money by selling resources to a VM. And constantly in real time, it compares those revenues and expenses. If its revenues are very high and its expenses are cheap, it's going to scale itself out. If its expenses are low and its revenues are low and its expenses are high, it's going to scale itself back. And we can do this at a host, we can do this at a storage volume, we can do this at an application based on number of transactions coming in and available CPU and memory or vCPU and vMemory in the host. The combination of finding the best place to run any workload and finding the most optimal amount of supply that you need is what actually creates, at any level of the supply chain, the assurance of the performance of the applications and the most efficient utilization of whatever infrastructure you need based on the actual demand that you have.
Okay. So I could have swore in early iterations of VMTurbo there was a chargeback model, And with all this information on supply, demand, and utilization, I know there's show back, but that doesn't help me. I want charge back. How come that doesn't seem to be on the schedule for VMTurbo?
So our primary goal is to provide a control system. To be able to provide a control system, we need metrics. And these metrics are driving decisions, but since they're in the system, we can expose them. That is the same, usually the same information if you do usage-based chargeback that you need to actually calculate what the charges are. To actually calculate what the dollar value of those resources are is not exactly our core IP. We use price as a means to abstract resources, not to represent necessarily the real dollar cost, but we can expose the usage information. And what we mean by showback is really to be able to feed this information to a chargeback system. There are a couple of others there, I won't mention vendors, that we have worked with, or together we can provide the instrumentation where we're not planning to calculate dollar cost. For real dollar cost to provide chargeback. There actually wasn't such a function, but we always exposed whatever part of the infrastructure we controlled and how much resources are consumed. Now there's a whole lot more that we control, so there's a whole lot more information that you could use. We're not calculating the chargeback function.
So one question, I mean, there's many questions being posed, but is there a way to establish defined SLAs so that way you can ensure that your system is defining and meeting said SLAs? Whereas in a virtual environment today, we kind of have the concept of, I've got resources, yay, here's my service level agreement. I hope to give you the resources that you want, when you need them. But where we can actually apply metrics to that, to be able to guarantee that uptime, that availability, that IOPS, and when we start to get outside of that, where we get visibility into that.
So inherently, our system will accomplish this because it will, so a couple of ways. By finding the best place to run a workload and scaling up the underlying infrastructure, you're going to be able to provide a level of service.
I get inherently, but I mean explicitly. I have an explicitly defined SLA that I need it to be able to achieve. This application needs 20,000 IOPS. This one needs this much network throughput. And when things start to become constraints on that, I need them to start evacuating nodes out of the cluster. Is that some of the capabilities that are kind of explicitly in addition to the inherently, yes, the implicit nature?
So we're actually doing this, for example, with OpenStack. OpenStack allows you to differentiate between workload. You could assign different CPU shares to one VM versus the other. What we do is we actually are allowing people to define what and this is just as an example, of course it can be done anyone, but it's actually something that is available out of the box, where we can say that this application will always, this virtual machine will always need this much CPU resources. And Eric briefly touched on our deploy/reservation function. It's a very, very important part of the functionality. If you blindly deploy applications in your environment, you're almost never going to be able to assure the performance of those applications. The way we see this as a unified control system is a single control system that controls the initial deployment of the applications, the ongoing operations, as well as the future planning of it. So what we do is our OpenStack integration integrates with the OpenStack scheduler, and as part of the scheduling function reaches out to VMTurbo and makes sure that the, for example, virtual machines are being provisioned only if for the really important VMs, and for example CPU shares can define the amount of CPU that you want to guarantee to that VM, are always going to be available, so that you either find the best place to allocate these VMs, both to assure their real-time performance and to guarantee the amount of resources that they need to be able to get from the environment. And as the environment changes, you destroy VMs, some VMs will change, it will continuously assure that as the applications will run in the environment. And of course, by using built-in functions such as CPU shares implementation in Linux kernel, we can actually make sure that even if you put 4 VMs, 3 of them are really, really important. The fourth one is not. The fourth one cannot overtake the other 3, so that you will not only have enough resources, but those resources will actually be available for those 3 VMs in the environment. If you deploy, and most of our customers are deploying our software in a full life cycle of the environment, I believe you can accomplish that.
Sounds good. Justin, where's your question?
Just trembling over for Justin here.
No, it's all good.
He's doing good.
It's going to nerd out on some details.
All right.
So the economic model that you have has an exponential function. Is it the same function for all resources, or do you have different price curves?
So a couple of things. You can adjust. And we are doing this inherently in our software, adjust how this function behaves. For example,
do you have one function, or do you have multiple different curves?
Sorry.
Yes, you can change the inputs. I know that. I get that.
Okay.
Does the actual mathematical function of price to capacity, price to utilization, do you have one, or do you have lots of different ones?
So we have designed the application in a way that any function can be plugged in. Today, what we ship out of the box is not a field configurable option. The design and the implementation of the system allows us to plug in different functions. Today, we plug in the same function.
Would that be a global function, though? If you change function, is it global?
No.
It's defined by the type of capacity you have too. So it's the pricing function is representative of the same relationship between usage and delay. But if you have a NetApp aggregate that has SAS and SSD, the pricing function will inherently be longer, right? Because you have more capacity. It won't be so when you think of your capacity and usage against that, it's representing the same relationship. So I guess I'd be curious. What do you see as the use case for multiple price functions? What action would you drive out of that? If you think about the use case for
relationship between, so if it's a utilization to capacity, if you're at 80%, then that is a price multiplier of X.
Yep.
That will be the same for any commodity. So what I'm thinking of is different commodities having different price curves. So for example, you could, I don't know why you would, because it wouldn't work properly, but you could just have a linear relationship between price and utilization, which would mean that it's a unified price step every time that you change from 1% capacity to 2% or 99 to 100.
Fair question.
So you could just change the curvature for different commodities.
It is possible to do that for different commodities. It is not an out-of-the-box configuration that we are exposing in the field.
That's cool.
It's a good question, though.
That's
it's a really good question.
Yeah, that's what I wanted to ask. So I have a couple of other ones.
Cool.
So the way that you set the ability for an application to buy stuff is you set how much money it can spend.
Yes.
Yep. So you just basically define that you are this rich and you are that rich. Okay. Does that, it sounds like that dynamically changes based on, so if I'm in the middle of a supply chain and someone upstream from me is paying me money, I have more money to spend, so I can then use that to buy commodities at different prices, yeah?
Yes.
Okay. So that means that more important things, that if they have multiple relationships up the supply chain, so if I'm an important supplier to multiple things, then I essentially have market power.
And you're going to be driving.
So I can actually drive everyone else out of the market.
Or you could drive more infrastructure to be provisioned,
right?
Because
it's almost
but
like
that means that I can economically I can squeeze out other people. So then I, as someone configuring this environment, would need to be aware of what that might happen. So if they're important because of supply chain reasons, yes, but it's the price just said, well, this one is actually really important to me as a human. I need to make sure that this other one over here has lots of money, or this guy is going to squeeze it out, and it'll get moved off to other resources.
So you're right. I think it's a good observation that this budget mechanism is relative. That if you are changing the budget on one side of your data center, then another rack of the same data center will influence how infrastructure resources are being provisioned. On the other hand, I think that ultimately that is what you really want to do by the way of managing a data center. You really want to differentiate applications and prioritize them accordingly.
Yeah, it's a feature, not a bug. It's more of something that you would need to be aware of that wouldn't be in. It's not obvious, particularly to someone who doesn't necessarily have a background in economics. Yeah. Okay.
You're doing pretty good for somebody who doesn't have a background in economics.
I wouldn't believe it.
Okay. Yeah, I suppose that's sort of the main one. The one thing I had is there a transaction cost? So, for example,
that's a great question.
Yeah, moving. So because otherwise you get flapping of resources moving around. Yeah. So do you model transaction costs?
There's a couple of things. One is that funny that you have developers, so I could talk about all the implementations. But one of the interesting things that we have implemented is that we've got this quoting system. So every application when it goes shopping goes like, well, I want to ask for a quote. And it says that, well, I really want a quote for this much memory and this much CPU and this much IOPS. And when any provider, any supplier of that resource will respond to the quote, it will look at its current utilization and it will say that, well, if this guy moves here, it will increase my utilization by this. So the quote I'm going to return is going to be the price of as if this guy has already moved, so that you don't get a ping pong effect. Now, on top of that, we also have a cost of an action because maybe this VM is better off, say, gets better IOPS and latency running on a different data store. But another one would too, except that one of them is a 20 gig VM and the other one is a 2 terabyte VM. So what we also do is we look at the difference, every entity on its own, look at the difference in the price between where it is and what quotes it gets from someplace else. And then it says that, okay, this is better, but moving myself would be this much cost. Is it that much better? So maybe a 20 gig VM will move, but a 2 terabyte VM won't move. Yep. So we do have a cost of action.
Yes, you do transaction costs. Very good. Very good. Cool. That's probably all my main questions, I think.
I think this is, just if I could toss in a comment, I think this is where a lot of operations managers are going. It's about the application at the top and guaranteeing performance by however you want to do it. I think this is kind of, if I could just talk a little bit about Cisco, this is what they're doing with ACI, it seems. You've got to align your infrastructure so that you can guarantee the performance of an application. This uses an intriguing economic model to do that.
It's real time too, right? Because that desired state always changes depending on the variable. So, the second you do something, you have to go back and analyze what changed in the last 10 minutes. So, this is why we get asked questions about the competition or, whoever, but it really is apples to oranges, because if you haven't defined the goal in software, then the best we're going to do is get closer to that goal, but how we actually control it will not be real time. We'll always be 4 steps behind it, pulling our hair, analyzing the data. So I think, there's got to, it's not, and a lot of people confuse this. They think, oh, VMTurbo is making these decisions and we're applying the rules. It really, if you think about it loosely and abstractly, it's unlocking your environment to make its own decisions. We're not actually injecting new technology. We're injecting the platform that basically says, let's let it decide itself. And it's your infrastructure. So as a pre-sales guy, when I go into each environment, no desired states to change is the same, because everything's different. And I think that's the really unique part, is that it's not a static state. It's fully dependent on your environment when you install it and the actions that are going to get you to that place.
I've got 2 quick questions. I'm looking for, you can answer 140 characters or less, so long as the answer is yes or no. So 2 quick questions. One was a question Brooke asked. The ability to gain insight into platform as a service type things like Cloud Foundry.
I saw the Cloud Foundry
yes
one.
Yes or no?
Yeah. No.
Okay. The second question is futures and plans around making the interface, I'll be nice, prettier? I'll use the word prettier?
Yes. So absolutely yes. I think that.
As a yes.
Let me actually comment on both of the previous questions. So longer than 140. Sorry. A couple of things that we are really focused on the user interface is not only making it prettier, but telling this story. I mean, it's great that we sit here. What we want is this story to jump at you. We are already navigating our user interface to a supply chain. We are showing the improvements in the actions, but we want this whole story to jump at you. Now, as a process of telling the story better through our user interface, we might as well make it prettier. So yes.
And practitioners, we like to install, collect data, and immediately be able to take action.
Yeah.
That's what anyone wants.
Yep.
If you do that, and done.
Yep.
The product sells itself.
Yep, exactly.
With a sales guy.
Exactly. That's exactly what we want.
Yeah, the third point of that is very important, and that's what a lot of folks in the industry have difficulty with. Is they like to install, collect data, and then they stop, right? And that's where we see the difference in how we act versus how a lot of other products are and how practices are. It's not just a product thing. It's the reason why all these products only collect data and then give you access to the said data is because that seems behaviorally in how we've gone about things for a long time. But a lot of organizations are moving. I'm just for Denneman's sake, I'm going to say DevOps one more time, so I got to make it. But you know, that DevOps culture and that new way of doing things is cloud is driving us towards these new things, which is why when we talk about what we do in the cloud extensions and being able to burst out as needed. It also answers an interesting question around cost, and you know, Amy's brought it up. I think everybody's brought it up around the idea of chargeback and actual real physical dollars is challenging in what we do because we represent a cost based on available supply, available demand, relative cost based on either of those things. Yeah, but there's a reason why rubles are worthless right now, right? Because they've relatively dropped in value because of supply and demand. So we don't attach an actual cost because we don't want to be in the purchasing of hardware business. And one of the challenges we have, even with the some of the cloud bursting stuff, is people have asked us, they said, oh good, you know, you have the economics built in, so you can choose the most economic model when I burst out to the cloud. We don't think of it as true cash dollar economics. So the decision to burst out to the cloud, as an example, will be done based on supply and demand.
Having said that, we can influence the price of the resources, and this is actually, to your point, one of the very interesting use cases for why we want to have possibly different price functions. The way you maybe get charged for Amazon services may be different than the way you purchase hardware in your own data center. There are some interesting details there, but those are the cases where we want to allow for differentiating. It doesn't necessarily mean that we're going to represent the real dollar value, but influence our actions based on the way you actually purchase infrastructure.
So with the model, the applications sort of sit at the top of your supply chain. You said that there's showback. Can you show what their expenses are as a report or something? Yeah. Okay, so that means that you're about 2 steps away from a chargeback anyway.
Yes.
I mean, you just have a Forex conversion.
Sometimes what people will do, to be honest, is costing models are all different depending on who we talk to. So it's kind of hard to create a uniform thing in the software that's going to pacify everybody. To be fair, but if you take the usage report, you take the allocation report, your usage or allocation based on chargeback, export it to Excel, write a formula that says I charge this monthly average, takes you 10 minutes. And you probably satisfy a lot of the use cases, but
specifically in the context of how you want to do chargeback, and is it $2 or $1.50?
Well, I'd say even that, because it's summarizing the actual sort of the real cost rather than what you think they are, because IT people have no idea how to do cost modeling. This is actually doing the modeling for you of what's really going on. So then you just take that summary amount, which is in utils, not dollars, but you just run a conversion and say, well, that equals this much budget, or more, that you've consumed a whole bunch of this, and you, Mr. Application, have more money than, the sales guy has more money than, I don't know, someone else who's not popular this month. Your app will run better.
So are you trying to compare basically your internal SLA versus your real cost? Is that what you're...
Yeah, you can use this to do that planning for you. Rather than trying to build that complicated cost modeling yourself, use this as a shortcut to get to the end result.
And then go back to the business owner and say, okay, here's your cost per month, per year, per whatever. Pony this up if you want more performance resources or performance.
More likely you'll end up saying, this is what I think my cost model should be, use this, and it'll go, they don't match. And then you can figure out where did I go wrong.
I can give you 2 examples just really quick, because I put VMTurbo in last year, and my company then, we had a very important point of sale application. So Windows EXE is on 4 RDS session host boxes, like a Citrix Zen app. And we get users logging into these boxes 24/6, so every day of the week. But we could focus VMTurbo on that executable across 4 VMs, and then what it would do is it would come up with some recommendations for where these VMs should be on which node in the cluster, which kind of storage they should have, if they're under provisioned with RAM, etc. And then the cool thing was, it could tell me that this engineering VM that I was also running was over provisioning was over-provisioned and costing performance on the point-of-sale application servers. So that was pretty slick, because that I could do that myself, but it's probably a 4 or 5 hour deep dive into the whole. But this was kind of automating it.
It's also, where do you begin, right? Because even though you've over-allocated in certain areas and certain virtual machines, there might not be a benefit if that's not taking away resources or causing constraints from other people. So the real battles you want to fight with that is, you know, where are the sizing decisions going to have the biggest yield to where my environment underneath is going? So you'll notice, you know, for efficiency, yeah, we pre-rank, you know, performance recommendations, but when you see this, I'm not going to deliver 90% of your environments over provision. I'm going to float the ones at the top that are easily justifiable based on the biggest benefit to that holistic desired state. So it's a great example.
Yeah. And you get more out of your CapEx, so you utilize your hardware better.
Yeah.
That's a great use case.
It's a really good use case.
We've found, and sometimes it's almost accidental when people, I mean, it's probably not good for the hardware sellers, because all of a sudden we enable them to get a whole lot more life and a lot more out of their existing hardware.
I felt really bad when I realized I over-provisioned a VM.
And the relativity is the important part of it as well, because, you know, it's making these recommendations now. We could go away in an hour and come back, and the recommendations will be different because everything has changed. You know, it's that classic, you know, read the prospectus. Past performance is not indicative of future results.
Very important thing that Eric just said. So when you think of the action scheduler in our system, this is critical, because imagine if I scheduled 4 resizes. What's the date today? Is it?
14th.
The 14th. Okay, so let's say I scheduled those 4 resizes to happen 2 weeks from now. If the scheduler would hardline that execution for that date, what if that action that I scheduled wasn't relevant at the time that window comes up? That could actually cause another problem. Right? So if peak load changed, if something in my underlying cluster happened, if I provisioned other workloads. So think of the action schedule as less of a way to just say, you know, automate this process. It's saying, here's the window of time you have, take the actions during this window that make sense based on the most recent desired state. So meaning we'll actually, you know, change those. Maybe we do something different so we don't, you know, cause an issue in the environment. That's just one important point that I think is really important.
Historical performance of the application influences the price, influences the decisions. So when we say real time, we don't mean point in time. We mean everything that happened up until now, and everything that is going to happen in the future, but that is a constantly changing state.
In practice, what kind of churn do you see, or, you know, flip-flop kind of movement, where the system will recommend a change, you make the change, and then something else will change where it recommends you change either back or change the setting again?
So this is what. So first of all, the goal of our software is to create as stable of a system as possible. We are, and this is why I said it's important that our software is considering historical performance, current performance, and future performance as it makes a decision, so that you don't go back and forth. Now, having said that, the way our software is going to control your environment is going to be different based on how dynamic the environment is. I've seen environments where they deploy 40,000 VMs and then they run it for a year, and I've seen environments where they deploy 10,000 VMs every week. And there's going to be a different set of actions that will assure the performance of these applications running on these VMs. This is why I think that the previous question about what is the cost of action is important. We want that to be also configurable to the point where I have a lot of dynamic changes in my environment, but maybe I want our software to only act on more significant differences because the cost of action would be too high otherwise. Or what we also done in our system is that we're not only actually out of the box, not only changing the cost of the action based on, say, how big of a VM do you need to move, but how many actions do you have in the environment. So maybe if you have 200 actions, then the 201st action is going to be more expensive than the previous one. So we're only going to be executing X number of actions at a time. In general, we really want to shoot for a constant but stable data center that assures the performance without more churn that's necessary.
Okay, and I have another question, and I don't know if this is going to sound like I'm being a jerk. I don't want it to sound, because I don't mean it to sound like I'm being a jerk, but So like 6 months in, after I purchased the product, what is the measurable difference? And what measurable difference can I show my boss to say, okay, I purchased VMTurbo, this is the measurable change, and this is how much more stable it is? What kind of metric do you have where I can present to somebody else and say, this is why I purchased this, this is why it's helping?
So I think there's a few different things, and I think it depends on the environment and the state when we come in. It depends on if the value you're trying to represent is a performance increase. We can talk about this. We can also talk about the byproduct of an increase to efficiency. So typically a customer will see about a 20 to 40% increase in density, both on storage and compute. So the biggest, I think, business deliverable as a function of this is, well, if we match supply and demand and we solve performance, then as a function of doing that, we're decreasing the investment we need to make in hardware compute, and that's really, really easy to show, and that's typically, you know, what they probably care about a lot of the time is, hey, I had 10 budgeted servers this year. I don't have to buy a single host for 2 years because VMTurbo is managing demand better. In terms of performance, it's unique because you could think of it on a granular level in things like response time and reduction in delay and latency, which are things I think we want to move towards, is capturing how do we actually represent this to a customer. Today it would be things like increase in incidents and alarms from your traditional monitoring tools. So I know this sounds kind of weird, but we turn monitoring tools green. We actually have proved it. So if you have an anomaly detection suite, and I won't name them, by automating us, we will literally turn the heat maps in those systems green. We'll see about 40% reduction in the alarms coming out, or the noise, which actually happens to make those tools function better. So they deliver more signal, less noise, the real issues that software can't really automate. So I'd say reduction in alarms, but also decreases in ready queue, decreases in congestion, decrease in complaints. Those are all kind of intangibles that, depending on whether you track that internally, that we could lean on some of those before and after. In pre-sales, we often will. We'll document it. We'll come in and we'll show you at the end of pre-sales engagements where we left off. So we try to capture that based on your own KPIs. I think in the future, we want to integrate, how to actually measure things like response time and how to actually measure that, tangible performance.
Yeah, but I think that today what we're doing, and so interesting side note, Eric mentioned that in a pre-sales engagement we are measuring the ROI. Most of our pre-sales engagements are fully automated before they purchase the software. They are realizing value from the software before they pay for it, which I think is great. So what we do is, as Eric mentioned, we are actually start measuring the ROI before you start spending, but we actually have a very strong post-sales team and a really good practice around how do we actually help you communicate that value internally based on metrics that Eric mentioned: reduction in trouble tickets, reduction in operational costs, the number of hours that you spend on figuring out which VM to move, and these are maybe less tangible than capital cost avoidance or capital savings, but I think they are very, very important part of the ROI. And we've got a practice basically that we work very closely with our customers to continue to help you to show this internally as you continue to use the software.
Well, it brings up an interest. So I worked with a customer and they asked the same question before they purchased, and it was a large environment. It was about 10,000 virtual machines, and they had automated in pre-sales. And so we do a full audit log of all the actions that we do. So an easy way to kind of show it is, okay, you've automated, maybe sizing, you've automated movement, you've automated storage. We get an audit log from the last 45 days in the pre-sales engagement. Basically, here's a bracketed column. 500 actions were taken to prevent ready queue before it became an anomaly. 300 actions were taken to reduce latency. 200 actions were taken to eliminate things like that. So it's just the number of actions in general that, this is where we want to bring you, is not just initially showing how to get there. When you apply automation, how do we control it like pressure in a valve so that PSI doesn't expand again? And just showing the sheer number of things that are done on your behalf as opposed to you doing it. I mean, that's pretty nice to be able to show. His software did this for me. I didn't have to, go in and flip the lights on and do the things I need to do. So that's an easy way, but it would just depend on what you want to show back. We'd work with you on that.
One question came in, and it was around from Thomas Bryant on Twitter about. He says, do you make action on one data point? And that's not true, but you want to explain what makes that decision to make a recommendation and to perform an action?
So, good question. So one is that the actions are identified by each entity, which, by the way, helps us to scale horizontally tremendously, because instead of having a central rule engine, we distribute the decisions into each application and each VM. But when each VM makes a decision, it actually, I mentioned earlier our implementation of, it gets a quote. It gets a quote for not one resource, it gets a quote for a basket of all of the resources that it wants to buy. And basically each decision that it makes is based on, I need 2 gigahertz of CPU, I need 4 megabyte of memory or whatever, and X number of I/O operations, and it basically compares the basket price. It's kind of like going into the store and you're buying your bread and your cheese, and then you look at the full bill, and you're like, well, I actually don't want to shop in this store. I want to go to a different store because the cheese was really good, but the rest of the stuff that I'm buying is too much. So basically, all of the decisions are made based on the combination, all of the things that matter to that particular entity's performance to satisfy its demand. So it is not a single data point in that sense. In another sense, we mentioned how we calculate the price. And we calculate the price based on this exponential function. It's actually a bit more interesting than this. What we do is we take a historical weighted average of all of the things that happened in the past for every resource. So instead of only basing it based on a single data point, the price of any commodity is based on all of the data points in the past with a decreasing importance as it happened a long time ago. So the prices have a historical aspect, and the decisions have a basket price effect, and the combination of the two is definitely more than one data point.
So when you instrument the cloud models, that's an OpEx model. You get updated compute per minute costs from like Azure or AWS. Can you tell if it was $1 per hour per CPU or anything like that would?
So today we are making an assumption that you have infinite capacity in Azure and in Amazon. So we assume a particular price for those resources. Interestingly, what we've done is that we assume that if you run your workload in Azure, it's going to be able to get all of its resources, but it has to pay the price that if your infrastructure was perfectly efficiently utilized. What that means is that if I'm running an application in a hybrid cloud environment, if I'm running on my private infrastructure and my private infrastructure is overutilized, the prices on the public cloud are going to be more attractive. I'm going to be moving out. But if I either add more capacity or my utilization drops, the prices are going to drop, and the same price in Azure now going to be less attractive. My workload is going to move back. So out of the box, it's not exactly a representation of the real cost. It is a way for us to drive bursting in and back, or out and back to the cloud.
So if you don't have visibility of the Azure or Amazon costs, or even the cost of physical hardware, or what it costs you to buy EMC, NetApp, UCS, or whatever, how are you recommending whether something bursts into the public cloud on Azure versus buying a new Dell or IBM array or something?
You want to stay out of Excel. In Excel, you're trying to figure out where it's cheapest to run your application, and you want to stay out of Excel.
Absolutely. So what I described earlier was actually making no assumption on being aware of the exact cost of the Azure. It was simply a decision based on performance, and of course all the other compliance and licensing and all the other constraints. If I am not able to perform in my private infrastructure, I move out. If I am underutilized on my private infrastructure, I move back.
Yeah, I think it's something that I think it's a good idea, and I think it's something that if you were actually to orchestrate an action, that's probably something you would analyze. And so I think today there's things we can do around it based on performance, but I almost relate it to a NetApp use case because someone asked me it once and they said, all right, so you've told me I need to provision a new array, and you've told me to, horizontally scale my NetApp, is it more advantageous from a business standpoint for me to buy a new controller or add more disk to my shelf? And he's like, can you calculate that for me? And I kind of told him, like, well, that's kind of a business thing that you need to determine based on, what's a more advantageous, negotiation that you want to have with your vendor, because you may be able to go to Azure and now say, hey, I'm about to burst a few workloads, lower the cost, and that's more of it's tough to capture that in software, but I think it's something we want to incorporate.
You can go and rent 30,000 IOPS in Azure now for $200 or $300 a day.
Yeah, it's
that might be more advantageous than buying some more shelves.
So I think that the very good point. So one of the things that I mentioned earlier is, at what point do we want to identify when you need more, when you need to buy more infrastructure, and it's based on the money that the entity makes and the money that it spends. And in the case of a storage controller head, it makes money by running all of the aggregates and the volumes on it, and it spends money on sitting in a data center and consuming power and cooling. So what we do is we actually track the relationship between the revenue and the expense over time, and if over a prolonged amount of time you continuously make more money than what you're spending, then we're going to suggest to buy another array, or if possible, provision one automatically. But if it's only a burst, we're going to burst into a cloud and then burst back into the cloud. So really, I believe that the combination of the two will allow you to have the right amount of private infrastructure based on prolonged workload, but being able to burst without necessarily having to buy.
One question also came in: what faults do you monitor or detect in a vSphere environment specifically? And maybe that's basically what are we monitoring and what are we making decisions on and making recommendations based on? You can just quickly run through a couple of them.
Sure.
That's an easy one. This is a softball.
I think the basic thing is we're tied to the APIs of what we do. So if there's something that fails for whatever reason to execute through the API, it'd be the same error message you guys see in relation to an action failing or things that don't go through. If your security offload settings between hosts aren't set right, things like that, those are all things that we kind of inherit when we take actions to make sure we're not making a problem worse. If a VPX agent fails, if things go down, we'll say check the hypervisor. So there's certain constraints we want to manage, but I don't know if...
Yeah, and in general, there is several performance metrics that are relevant even before they fail to drive actions, and we actually kind of mentioned a few of them between ready queue and I/O operations and storage latency and virtual memory and virtual CPU and swapping and ballooning levels of utilization. And of course, we detect when a host is not available. That's a very obvious one. We don't want to start moving workload to a host that just dropped off the network. Our goal is not so much to replace a fault monitoring system. I think that couple of things that we are considering is to influence the price of a resource if the system degrades. This is not part of our software, but released today. But if you've got dual power supplies and one of the power supply dies, maybe that host should be now more expensive. So we have the ability to do this, but we are not intending to replace a fault management system. I think that if you've got HP Insight Manager, it doesn't really matter who the vendor is. You probably still want to fix broken power supplies in the environment, and as much as we want to keep your environment at a desired state, the only thing that we can do is to work around those problems, is to move VMs in a place where they are running at a level of performance without a significant risk. Someone will still have to fix a broken RAID group and plug in another replacement disk. Hopefully they're hot pluggable.
In a way, you see yourselves definitely as a performance management application, and then you'll use Virtual Center, SCVMM or something like that for the actual fault management. So if if a NIC was to die on a server, or a NIC uplink was to die on a server, that fault will be bubbled up through vSphere, and you'd then get emailed without. But you're not going to do anything of that unless it impacts the performance of a VM, and you'd move things.
Well, so, for example, a dead NIC card will reduce the capacity, which will increase the price and makes it less attractive for the VMs. Right. But you still have to go and fix the NIC card at one point.
But your app is actually not going to tell us that a NIC card has failed.
No, it's going to
it'll say something like,
we'll let you sleep. Yes. We will price the resources accordingly until the morning, or until your tool of choice wakes you up with your pager at night.
Network throughput congestion. We'd move the VM before.
Now, one good thing, especially for Julian, just because I always want to say this, is you notice that we have a policy tab, and we talked a lot about some of the stuff that we do. We kind of drive folks to the policy tab to do some of that enhanced stuff, and it's, policy is king. That's why we're doing a lot of the things we're doing, is because the policies should help to define. The beauty part is that you don't have to do policies; they're already, baked in. But I know you'd appreciate the fact that we do have some really good policies, and they extend down to an amazing amount of granularity depending on each entity. And Jeff highlighted one before. We can go down to specific executables based on that, and that drives up and that affects the pricing ultimately in the end.
What I think is, just to add more point to Eric's comment, is that it may look like a policy tab. What we actually do is the exact same market, the exact same scaling engine. Changing something in a policy tab, software licensing creates a commodity, influences the prices, drives the decisions with the same engine. It's not that you define a policy and that will override something that we are doing. It is a single unified control system. Everything that feeds into it drives the same set of actions using the same market mechanism.
For example, if you had licensing for, say, Oracle, and you had licensed 4 hosts for Oracle, and somebody goes and installs Oracle on another VM, you don't even know about it, a developer goes and does it, will this policy engine, through its WMI query, go, I've got Oracle on there, I need to therefore run it on those?
Yeah. It's not a policy engine, but it is the economic scheduling engine that will do that.
It creates the commodity of that constraint, right? So if you say, and I'll actually show you this because I want you guys to actually see how it works, but if you dynamically group the physical machines based on criteria, well, tell us what the license hosts are, right? By name, by CPU model, whatever it is.
CMDB feed.
And so now if it goes from 4 to 5, as long as your criteria was correct, the 5th host will add itself to this group. So now you create another policy based on OS or based on the name of the workload, if it has Oracle in it, dynamically groups itself. So now when you create a placement policy in our system, you're essentially creating that commodity constraint. You're saying anytime I provision Oracle, dynamically assess whether I'm adding and subtracting new machines, provision the hosts within that are part of that rule, right, into that group, and now I'm creating the commodity that will last throughout the life cycle of that workload. So if someone places Oracle off one of your provider groups based on that commodity it buys, it will have an action based on compliance to say move it back. And the key there is if we move it back within that constraint, it's a trade-off, right? Because we're not just going to say move it to this host randomly because you violated it. We still analyze performance. We still analyze the characteristics of the performance on those hosts when we correct that. So those are certain constraints you can place and essentially have it flash at someone and say, you're in violation, move it now.
But you're also auto-discovering the applications because you're not using a DRS affinity group and having to manually drag your VM into that to say, this is my Oracle group. This is just discovering Oracle is on there and sorting it out. That's nice.
We're rounding down to, we have about 5 minutes left, and which is great. This is the best thing you can have, is that we didn't get to nearly anything that we wanted to, but we talked about a ton, which is really cool. So we did have some other stuff to.
Well, is there anything in particular you annoyed that you?
No, not at all. This is precisely what it is, because I know one of the things we've had in the past is, we want to focus on the fundamentals, the why, which is the very important reason that drives the economic scheduling engine, the reason why we do all these things. And this has been you guys have all been a great audience, and this is really cool. And everybody online, this is awesome. Just to briefly. One thing that, just because my baby, my OpenStack business, and I saw Amit saying he doesn't want to touch OpenStack, probably it's a lot of people are thinking that right now. One of the things that we're doing with our OpenStack integration is about trying to help to create some of the, I call it feature parity with the ability to control that we do in VMware environments, because OpenStack inherently just doesn't have that. And that's one of the big gaps where as people are looking to adopt containers, and just for everybody, because I know you there's Docker. I gotta say Docker a few times.
DevOps.
And DevOps one more time, just for
but you did mention Cloud Foundry and PaaS in general, and really the reason that we are working on controlling the containers is to help people deliver a platform as a service on top of maybe an infrastructure service that we're already controlling. So where we are going with containers is exactly the type of integration that I think you asked about earlier.
The actions change. That's pretty much it. I mean, it's the same problem, but now it becomes integration to the Nova scheduler, Salometer, Cinder. All the things that you can do in OpenStack become available for us to control. Docker containers. If it doesn't have a limit, we don't want to size it. We might say, provision new Docker containers as opposed to change the size of it. So it just changes the way the control system works, but the mediation gets brought into the same problem definition. So,
have you expanded your storage support?
Yeah.
So I know you have NetApp. Who else?
So any IBM? Just out of interest.
So that's on our list for this year actually. We have added HPT we're working with actually flash vendors. We're going to release one of those guys very, very soon. So it's.
The flash one is a particularly interesting one because we've talked about constraints and moving constraints. I mean, I'm a big fan of theory of constraints, so Eli Goldratt is like my hero, and a lot of really good things come of that. And that's a classic case where if you take flash and you put it underneath a host, we always talk about the overhead of storage and ready queue, and general overhead is like 2 to 4%. As soon as you put flash underneath that very same host, the CPU goes to 40%. The exact same workload. And you would have no way, your DRS rules and all of those things that we've carefully crafted for that previous infrastructure now are no longer valid. And that's why you let it dynamically decide based on the actual demand that's happening at that time and makes those control decisions based on real demand that's going on continuously in real time.